The Tunnel of Samos is a nearly mile-long aqueduct built in the 500 BC time. They used mathematics to figure out how to make a nearly straight tunnel through a small mountain. They kept track of right angles coming from two selected points of the mountain to cut. They kept track of horizontal and vertical lines, added and subtracted where appropriate to get the vertical and horizontal lines of a right angle. Then, the hypotenuse of this right angle is the straight line through the mountain. I bring up the Tunnel of Samos before talking about Thales because it suggests that there were more Greeks gathering mathematical knowledge than just Thales and Pythagoras. These two are generally credited for kick-starting Greek mathematics, Thales of Miletus being first. Thales is most famous for predicting a solar eclipse and calculating the height of the Great Egyptian Pyramid. Even if true, his real mathematical significance is introducing logical proof into mathematics. There's some debate on whether the Babylonians had logically proved the Pythagorean theorem before the Pythagorean discovery, and the introduction of deductive logic by Thales. One thing is for sure, there's no Babylonian tablet explaining modus ponens syllogism, and showing how to use this new magical tool to prove, logically, the Pythagorean theorem. They don't show where they get the result from, they just use the Pythagorean formula to calculate Pythagorean triples. The Babylonian and Egyptian mathematics was a form of having the solution first, and working your way backwards, listing results as tables. In Egyptian division for instance, they would make tables of multiplications, and then notice that a certain table corresponded to a certain division. The Babylonians did the same for algebraic equations. They had listed tables of squares and even cubes, and inverses, and in almost a Cartesian graph of, go over so many spots, and up so many spots, and that's your solution, they'd solve quadratic and even cubic equations. It must have been surreal for the calculator to go through a library of these tablets arranged on shelves, for various tables and getting the calculation for this or that star position. That's what they did. The Iron Age Greeks went and collected all this knowledge, and somehow thought of logical proof. The Greek philosophers took to mathematics and logical proof, and caught a glimpse of learning nature without the God hypothesis. But, as we'll see, they could not make the mathematical philosophy, mathematics as the holistic viewpoint, as I'm showing here, before the right-wing Romans, and others closed in. Getting back to Thales, Thales reportedly proved the following theorems. Diameter bisects a circle, base angles of an isosceles triangle are equal, the theorem that I show the proof of at the beginning of this Gospel of Truth, vertical angles are equal, if you cross two lines, the opposite angles formed are equal, no matter their size. Two angles and a side of a triangle makes triangles congruent. This is the theorem Thales used to calculate the height of the Great Pyramid and how far a ship is out in sea. Any angle in a semicircle is a right angle. This last theorem uses the isosceles base angles are equal theorem. Draw a line from the center point of the semicircle's diameter to a point on the semicircle. Then draw lines from that semicircle point to the semicircle's endpoints, on the diameter. Now, you have two isosceles triangles in the semicircle. Adding up angles A plus B gives 2A plus 2B. Factoring out the 2 gives 2A plus B. The right angle is 1/2 the triangle 2A plus B, so the 2 cancels out, leaving A plus B. It's curious that Thales is not credited with discovering the Pythagorean theorem. Of course, we know that Pythagoras likely got his knowledge from the same source as Thales got his, the Babylonians. One has to wonder if he came up with the first logical proof of it first though. And as we saw above, the Greeks were building the Tunnel of Samos at the same time as Thales was discovering his mathematics. So, the Greek as a whole had to have known of the Pythagorean theorem before Pythagoras. I'm thinking Pythagoras' real claim to fame here is in actually proving it, whereas before, the Babylonians and the Greeks who built the Tunnel of Samos used an empirical version of it. The Pythagorean proof probably consists of moving equal-sized right-angle triangles in a square, such as to form two rectangles. There's 4 of these right-angle triangles that you start with. You match them up to form two rectangles, and position them in such a way that you can see a large square on the side of the long leg of the right triangle, and a small square on the short leg of the right triangle. If you rearrange the triangles back to where each of the long legs of each triangle corresponds to a side of the square, you should see an even bigger square on each triangle's hypotenuse. This shows that the square of the hypotenuse is the sum of the squares on the short and long legs of the right triangle. If you did this without being cognizant of what logical proof is, you've probably missed the significance of what you just did. Pythagoras then appears to have invented the mathematics of musical scales. And he founded a mathematical philosophy school, where everything is number. This Pythagoras school is generally credited with first recognizing mathematics as an abstraction. They noted the nature of abstraction in mathematics, that two birds and two stones are concrete manifestations of the same abstract concept. And they tried to think of everything as numbers and fit it in with spiritual concepts of resurrection and spirituality. Later, Plato would be heavily influenced by the Pythagorean philosophy. The Pythagoreans would logically prove the irrationality of the square root of 2. Because this destroyed their faith that everything was number, they took Hippasus, the Pythagorean who made this logical proof, out to sea and drowned him. The logical proof of the irrationality of the square root of 2 is a classic. So, I have to show this. Start by radical, or square root 2 equals a, b. They equate it to a rational number, because the Pythagoreans thought everything could be simple numbers. To take the radical off the square root of 2, we square the equation, getting 2 equals a squared b squared. Multiply this equation by b squared to get rid of the fraction, gives 2b squared equals a squared. A squared must be even, so we can write a equals 2b and substitute back in our last algebraic re-expression, gives 4b squared equals 2b squared. Dividing out by 2, gives 2b squared equals b squared. We can do this the other way, giving b squared is even, which means we can reduce further, contradicting that we can't reduce further. Which suggests an unending sequence of numbers, an irrational number. Theodorus would use much the same logical argument to prove the irrationality of the square root of 3 up to 17, and in doing so construct a spiral. Much of this theory would make up Book 10 of Euclid's Elements. The Pythagoreans also proved that the 5 Platonic solids are the only possible three-dimensional solids. Some say Hippasus was taken out to sea because of this discovery. Whatever the case may be.